Well, as Christopher just pointed out, it helps if the teacher shares his screen so they can see the PowerPoint. So welcome to round two, which will be the only one uploaded. So for those that are watching after the fact, I got a few slides in and one of the students sort of said, "You're an idiot," and not using those words, he was very polite. He just pointed out the fact that maybe we should be seeing the PowerPoint, not just listening to you ramble. So, welcome back for those that are actually live with me this morning. And let's try round two for chat module 13 and Internet Control Message Protocol. And sorry for the repeat, but we'll just get through it. It'll be slightly different words. Okay, so basically we use ICMP to check for network connectivity between devices, and the two commands that we use the most within this testing regime is ping and traceroute. And we do this because it allows us to get messages back on the condition of the packet handling as it goes through the network. So ICMP provides feedback on the processing of IP traffic. Now, not all of the messages will be allowed to return because the security of the network from external sources, you tend to lock down ICMP messages because they can confirm the existence of a host to a hacker. So they will know that the IP address is valid, and then they can concentrate on working on attacking that IP address. So you don't want to necessarily advertise this protocol out to the world, but you want to be able to access elements of it within your own network for your own checking purposes. So what we want to get back is the reachability of a host, whether the service is unreachable, and whether timeout exceeded. Now, one of the things that will occur when your time exceeded comes back is a simple does it exist, doesn't exist question. Okay, whereas if you get a host is unreachable, that's a positive message saying that that can't go through. Whereas if you just block the reply to a ping, okay, you get a time exceeded coming up. So it'll allow the incoming request, but it won't allow the reply to come out. Is one of the tools that we use to force the fact that we don't want messages to be sent out to the internet, for example. So echo messages, i.e. ping, are used to test whether a host is reachable. So the way it works is within ICMP, the actual part of the protocol is echo and echo reply. So we send a echo request out to the host that we want to check the connectivity to, and it will reply to that request saying, yes, I'm here. And that's basically how the ping command works, is it uses echo and echo replies to establish connectivity with the target, and you get statistics because you got timestamps on when the message was originally sent and when the reply comes back. So you'll get messages that will tell you what the round trip timer is and delays and all that lovely information. because of the timestamps and the way the replies work. So the codes that come back, for example, on destination or service unreachable, is the network is unreachable. In other words, we can't route to that network. The individual host is unreachable. The protocol is unreachable, or the port is unreachable. So these messages tells you whether the network exists, whether the individual host exists, and then it comes down to whether a specific protocol or application is available. So you can see, if we manipulate the ICMP protocol and its messaging, we can gather quite a bit of information regarding functions within a network. This is why it's a potential security issue. Alright, so IPv6 are slightly different in what comes back, because IPv6 protocol is slightly different. So instead of protocol, it says it's beyond the scope. So we have issues. So host unreachable means communication is prohibited, i.e. normally from a firewall perspective. So you can see that we can gather quite a bit of information back. So when we send a message out there, every time it goes through a router, basically or above, so a layer 3 device or above, it will decrease the time to live field as the message travels through the network. And when it gets to 0, the packet is basically dropped. So you will get what's on display there, the time to live expired in transit, means the message went too far and basically just disappeared into the ether due to natural causes. Okay, so aged out. But you won't necessarily get a message back depending on how the systems are set up. So if your TTL expired, you'll get a reply from the device saying, yeah, this message is too old, I've timed it out, here's a reply. Now, time to live can be referred to as exceeding a hop count limit. Now, what we mean by a hop count is every time we go through a router, we're hopping from one network to another. So we refer to the handling of an IP packet via a layer 3 device as a hop. Okay. Excuse me. Now, another thing there is traceroute. We manipulate the time to live field using in the traceroute command to find the next hop along the path. So the first message sent within a traceroute will have a time to live of basically 0. So the next device it hits says the time to live field is dead. Send a message back saying I'm discarding this, and then that tells it what the next hop was, and then it increases the time to live field by 1, so it can get 2 hops, and so on and so forth, till it reaches the destination. So IPv6 uses neighbor discovery, if you like, as part of its functionality. So remember back when we were talking about messages within IPv6, router solicitation, advertisements, and neighbor counterparts. So the inbuilt functionality uses some of these other features that are built into IP to enhance ICMP, is what we're saying here on this slide. So router solicitation, advertisements, and that have a time. So every 200 seconds, it'll send this message. And within that message, in that router advertisement, it will have the addressing information, as in the prefix length, where the DNS is, what the domain name is, and things like that. So hosts that are using the auto stateless address system, Slack, will get some default gateway information, create its link address, and that's all derived from those messages. So ICMP is integral to the way the automatic addressing works within IPv6 networks. So basically, we send an advertisement saying, this is the network. Hi, how are you? All right. The host replies going, well, I really need more specific information. And then the router replies with more information so the host can boot up. So one of the things that is inbuilt into this round robin is duplicate address detection, because every address, even within IPv6, needs to be unique, just like within IPv4. And because we're doing it automatically, we need to have some method of detecting whether the address is used or not. Now, this system does exist within DHCP as well. Okay, that's why we don't get duplicate IP addresses issued when we're using DHCP, even if our addressing pool encompasses static addresses. Okay, there's always a pulse going out from the DHCP server checking to see what IP addresses are being used. And RSC 4861 is covering that duplicate address detection. So MAC addresses, as we talked about in the IPv6 chapter, we know that MAC addresses can be used to create our unique addresses if we need to. And one of the things that we can actually request is the MAC address of the target. And you're going, why do we do this? Well, we do this in IPv4. It's called address resolution. And one of the things we need to do is match a layer 3 address with a layer 2 address for every movement within a network. So we do this to match the two things together. Okay, so that's inbuilt within ICMP in version 6. Ping is our standard go-to test for connectivity. And as I said earlier, it uses the echo command set within ICMP. So it sends out a echo request, and the target will send back a echo reply. Now, depending on your operating system, it will determine how many of these it sends. In a Windows environment, the default is 5 echoes for every ping command. You can change that by using an extended ping. So you can actually specify how many pings you want to send or whether you want it continuous. By default in Linux, it's a continuous ping by default. So you actually have to do a control break, which is generally Control C, to stop the ping command from continuing in Linux. So what do we get? We get a timeout, a dot, and exclamation marks for a successful reply. And what this will tell us is a percentage of successful replies we get on the total send. And then we'll get our timing messages. So we'll be told the minimum, the average, and the maximum time it took for that sequence to occur. Whenever you're trying to connect to a new IP address, you will normally always have the first one time out on you. The reason is it has to do that matching between layer 3 and layer 2. So it's actually, first thing it's doing is it's trying to do that address resolution. So that takes a bit of time, which times out the first sequence. So if you ping a second time directly after this or within a few minutes, it already has that resolution and it no longer needs it. It just has it in its table and will give you 100% response. One of the ways we can test whether our network card is working on a device, besides physically turning it around and looking at indicator lights, is ping its loopback address. Now what happens is the mechanism for talking to the physical media is shunted back into the network card. There's a little shunt, and what happens when you use the 127 network address is it engages this local loopback, and it doesn't actually put the ping, the echo request, on the media. It actually loops it back within the network card, and the network card replies to itself. One of the first things you should do is check that you can get to the local gateway. That tells you that any switching between your host and the gateway is still up. Okay, so you might have a switching issue or cable issue, and this helps you isolate the area of the communications issues. So if you can get to your local gateway, you know that it's getting to the router. So therefore, the cabling between the host and the gateway is good. If you can't reach that, then you're looking at an issue between here and here. So you've already isolated where the potential problem is, and you can then work to eliminate the various elements by, okay, if I can't ping my gateway, can I ping is my network card working? Okay, so putting the last slide, we had successful pings to 127, so we know the network card's good. So do we have a circuit to the switch? Do we have a problem with the gateway address configuration? within the protocol. All of these things help you narrow your search for the problem. So after confirming we can get to the gateway, you then will expand through the network to find out whether you can get to another device, so a remote host. If successful, everything's working as far as IP is concerned. That doesn't mean you've got functionality on an application level. It just means you have a working path between the two devices. So this is eliminating issues from layer 3 down within the ISO model. You may still have issues upstairs of that. So again, it's all about eliminating potential points of failure, which is causing you your connectivity issues. The other command is traceroute. Now, traceroute will basically allow us to get some information back on every intermediate device along the path between those two endpoints. Now, depending on the device that you're issuing the command on, if it's a router, it's a traceroute. If it is a PC, it's normally something like traceRT. And basically what you're looking for is confirmation of the device name. So these are the hops, and basically it'll give you an IP address or a device name and the round trip timers that it took to get there. If the ICMP functionality is blocked, in other words, it will not send a reply, you'll get an asterisk coming up here confirming that it's gotten to the next hop, but it cannot get specific information about that host or intermediate device coming back. That's very common. So, as I said earlier, the first time to live is there. So what we do is when we're pinging from, alright, so we're tracing the route to 192.168.1.2, which is here from this device. So if you want to look at how many layer 3 devices it goes through, that's a layer 2, layer 3, layer 3, layer 3, layer 3. So 1, 2, 3. So it needs at least a time to live of 4 to get to its destination. So the traceroute command, as I said earlier, it'll use the time to live field to get information on each hop along its path. So the first request will go out with 1. When the device picks it up, it decrements the time to live down to 0, says, okay, I've got to discard this, and sends a reply. Next message will come out with a time to live of 2. So goes through here, goes to 2, goes to 1 as it comes out, gets to here, goes down to 0, got to discard it, send a message back. That's basically how traceroute works. And we use traceroute to help us get an idea of a routing issue within a network. So if it can't get to a next hop, alright, so if we can't get passed here, alright, if we know our network, which we should have a fully documented network, we would be able to see that we're not getting replies between these two devices. So we could then, using traceroute, log in remotely to these two devices to work out what the issue is, why these two devices are no longer talking to each other. For an example of where and how we would use traceroute. So within this module, we have a couple of packet tracer activities to do that will show you how ping and traceroute work, and please do them because it helps cement the functionality of the protocol and hopefully gives you a better understanding of how it works by going through the process. Now, we had a look at ICMP v4 and v6, which are basically giving us the same messages, but they use different terms between the protocols. And in v6 environment, it uses the IP RS and RAs, and so basically the router and neighbor advertisements and solicitation messages to help deliver and maintain communication through the network. We looked at how ping is used to check connectivity between end devices, and we looked at traceroute, how it uses the time to live field to trace each hop along a path between two devices. Now, again, these commands are meant to trace connectivity between end devices. When we use them to check connectivity between intermediate devices such as routers, we can get different characteristics occurring. We'll explore those characteristics in the next unit, so CCNA Module 2, where we explore routing and switching in more detail and introduce the protocols and that we use in setting up routers and advertising routes and all that sort of stuff. So we'll expose you to the unique situation that the ping could give you false information because it's not designed to work between those devices. So if you're aware of that, if you're aware of how it works, you can work out whether you're getting a false negative or not. And that's the end of it. So it was a very quick chapter, this one. Effectively 20 slides if you discount the start and end, which I always do. So that's that one.